To use the I forgot what you call it, the
Tan
tan
inverse.
inverse.
Yes, so A is equal to the tan inverse of 2.0503, and you have to type in the whole thing. Alright, so the tan inverse, so second function, tan inverse of 2.0503 is equal to 63.99 degrees. So did you all get that? Exclusion, Shazay? Yeah, that's fine, because it was 9999999. So that's no problem, right? So so you all okay with this tan inverse and using it on the calculator, right?
Right.
And I'm sorry Ariel wasn't here, because I know Ariel had some problems with it, right? So I really hope, right? So could you all just give me the answers for number 2 then? Z would be the cos inverse of 0.1219, which is cos inverse. Yeah, about 83 degrees. Oh, they said here to the nearest degree. Okay, you see, I didn't read the question. Right? Y is the tan inverse of 0.6494, which is 33. What's number 4? The sine inverse of 0.8746.
61.
Thank you. V is the cos inverse of 0.6820, which is
47.
how much? 47?
Yeah.
C is the sine inverse of 0.2756, which is 16 degrees, right? Sine inverse of 0.2756. Yes, about. Good job. Right. So now we have these questions here, and of course these questions all had answers. So let me ask you something, right? These questions in this first set, for the people who tried to attempt at least some of it, right? Were these questions okay, easy, hard, difficult? How did you feel about them?
Very good.
Yeah.
Yeah. And Soraya, how did you feel? I know that you were having some problems with it.
Not entirely bad. I mean, I see figure out one to figure out the rest.
Yes, very good, exactly, right? So at the end of the day, it's all about identifying the sides. So let's just write our right? And I was always write that, right? So as seen here, I want to find the angle. Let's call it the angle A, right? And the angle A, I don't know what do I need here? What is this? This is the hypotenuse, and this is the opposite. So we're talking opposite hypotenuse. So the sine of that angle is equal to opposite, which is 51, over the hypotenuse, which is 55. The sine is 51 divided by 55, 0.92727 recurring. So therefore A is equal to the sine inverse of 0.927, which is A is the sine inverse of that is. Did you guys get 68 degrees for this?
Yes, sir.
Yes, sir.
Right. Now we could see here that this is also sine, right? This here is hypotenuse over opposite, right? So let's call this the sine A is hypotenuse opposite 19 over hypotenuse. So therefore A is equal to the sine inverse. Now I prefer you do this. You see how in this question, I went and divided first. Well, dividing it gave me an incorrect answer because the actual answer, 51 divided by 55, the actual answer was 0.927927538, blah blah blah, going down the line, right? And I approximated it here. Yeah. So instead of actually making this divide and then approximating it and then finding the sign inverse of the approximation, that will give you something that's off, right? So if you want a more exact answer, find the sign inverse of the actual fraction, 19/27, right? So I will just do that, the sign inverse, and then I'll open brackets on my you see the brackets on a calculator? Always use brackets. If you're not using brackets, you're doing it wrong, especially with this kind of thing, right? So I just literally typed in what you see here, sign inverse, open brackets, 19/27, close brackets, and then press enter, and I got 44, well, to the nearest degree, so about 45 degrees, right? You all got 45 for this one?
Yes, sir.
Yes. So of course, to the nearest degree, is easy, but when you're talking about to the nearest, 4 decimal places or 5 decimal places, well then you'll start to get problems when it comes to right. So make a note of this, don't do the divide yet. You can actually do the sign inverse to the actual ratio and you'll get a more exact answer. Now, oh gosh, all of these are the same thing. Well, at least these 4 anyway. So what is these 2 here? What do you get for this one? If anybody did it. A is the sign inverse of opposite over hypotenuse. So 34/55. Alright? What y'all got?
38 degrees.
Yes, 38 degrees. And over here, same thing. A is the sign inverse of the opposite, which is the 14 over the hypotenuse, 24. So the sign inverse of 14 on 24.
36.
Caitlin is here. Yay! And Caitlin, yes, very good, Caitlin. 36 degrees. Caitlin, you came in like Wonder Woman there. Such a fantastic entrance, like an exciting action entrance almost. Yeah, you came in and it was like 36, and it was just so confident and sure. Great job there. Right now, this one here we kind of dealing with a different one because we could see here. What do we have? We have, well, this is the angle. But this is adjacent and this is opposite. So SOHCAHTOA, TOA does use opposite and adjacent. So we're actually dealing with tan A. So this would be the tan A is opposite 29 over adjacent, which is 38. So A is equal to the tan inverse of 29 over 38, which gives us what? Are you all just working it out, or are you all do you all actually did it and have it in your book?
No, I do it.
Alright.
To be honest, I kind of forget about the Cyclic Theorem, so that's why I didn't do that one.
Yeah, that is the one that I was real super interested in though, in terms of you guys doing. But don't worry, we'll get there, and I will allow you to do it on the spot. Right, since you were so honest, yeah. So we can see here this is adjacent as well as opposite. So we come with 2 tan questions. So this is tan A is equal to opposite over adjacent. Right, that is the rule. So therefore A is equal to the tan inverse of opposite over adjacent, which is nice job, 22 degrees. Right? We might cut through these things good now, right? Oh, by the way, I mean, it have answers, so all it could just be telling me the answers from the answer sheet and nobody didn't have to do anything. Jeez, I'm so gullible. Wow, you're beat me. So over here we have the same kind of tan situation. So A is the tan inverse of opposite, which is 34 over adjacent 42. Right? So the tan inverse 34 over 42 gives us what?
39.
Yes, very good. And over here we have something a bit different. Now we could see here we have adjacent and hypotenuse. So you know, in car is the car we use in here, adjacent and hypotenuse, right? So we can see here that we have to use cos. So the cos of the angle is the adjacent, look at it, over the hypotenuse. So the adjacent is 52 over the hypotenuse, which is 56. So therefore A is the cos inverse of 52 on 56, which gives us 22. Very good, thank you. Soraya, how are you feeling about all of this stuff so far? Pretty okay?
Yeah.
Alright, good. Alright. Soraya, you sound really excited. Are you really, really excited?
Yeah.
Yes, I know that. I know that. I was feeling it. I just getting the vibe, you know? It's getting the vibe, yeah. So what we have here is adjacent and hypotenuse. So that's another car situation. Chicken in the car and the car can go. You already remember that one, no? Cos A is equal to adjacent over hypotenuse. So that is 8 over 17. A is equal to the cos inverse of 8 over 17, which is 62. You all got that? Yeah?
Yes,
Yeah.
sir.
Are they reached this far or are they stopped in the first page? Adjacent over hypotenuse, so this is another cos situation. So I could skip the A is the cos inverse of adjacent, which is 13, over the hypotenuse, which is 18. So the cos inverse of 13, I make a mistake on the start of it. Cos inverse of 13 over 18 is 44 degrees, right? You all need me to do all of the rest, or you all think they're good with this kind of stuff? How will you feel?
It was good.
Alright,
Yeah.
well, I only hear one, so I'll do a couple more, right? Over here we can see that we have opposite and adjacent, so this is a sine situation. No, opposite and adjacent. Toa is a tan situation, opposite and adjacent, right? So A is equal to the tan inverse of opposite over adjacent, which is the tan inverse of opposite 34 over adjacent 39, gives us 42, which happens to be one of my favorite numbers, right? Did you guys know that 42 is the answer to life, the universe, and everything?
I think we solved the triangle questions on the image.
Yeah, but I guess because we have three sides here, we could actually use two different ones. So let me just do one of these, right? Using two different ones, and we'll get the same answer, right? So we could use all right, let me use all three. Let's use all three and see, right? So the angle A is the sine inverse of which sine? So opposite over hypotenuse, right? So the opposite, which is 76, over the hypotenuse, which is 95, right? A is also the cos inverse of adjacent, which is 57, over hypotenuse, which is 95. and A is the tan inverse of opposite, which is 76, over the adjacent, which is 57. Opposite over adjacent, yeah? And see if you guys get the same answer for all of these. So the sine inverse of 76 over 95 is 53 degrees. Cos inverse of 57 over 95 is 53 degrees. And the tan inverse of 76 over 57 equals 53 degrees. No problem there. And yes, look, we have the 53 degrees there. Okay, nice. So find the measure of each indicated angle round to the nearest tenth this time. So this is the same kind of thing here. So essentially, what do we have? This is the angle A. Let's call it A for easy purposes. We have adjacent. No, this is hypotenuse actually. So this is hypotenuse and this is adjacent. So that's cos, right? Adjacent over hypotenuse. So the cos, the cos inverse of adjacent over hypotenuse gives me cos of adjacent 12 over the hypotenuse 13. What do you all get for this? 23? 22.6?
Yes, sir.
Alright. So this one here is adjacent over opposite. So we're going to use tan. So tan inverse of the adjacent over opposite. No, it's opposite over adjacent, sorry. Opposite 4 over adjacent 13. So that is the tan inverse of 4 over 13. If you all just give me the answer, it would go a lot quicker. 17.1, right?
Yes, sir.
Alright. So all of these are pretty much the same. You can tell that this is going to be a tan. This one here is hypotenuse and adjacent, so that's cos. This is tan. Soraya, do you need me to do any of these here? Just these beginning ones. You okay with these? Alright, any problems at all? No confusion, no anything? You're clear on that?
No, when you did it, yeah.
When I did it?
Yes. No, I was trying to take this out.
Okay, alright. What about you, Caitlin? You okay with this stuff?
Okay.
I don't know why that just did that. Alright. So let's move on to this. Find the measure of each side. So at the end of the day, I could have skipped this because we was doing this in the last worksheet where you're just finding the angle, and you could see by finding the angle we had to do cos inverse. But when we have the angle, we don't need to do cos inverse. We don't need to do the inverse at all, right? So we do have to decide which trig to use. So I'm going to write my right? So we see here that we have adjacent and we have hypotenuse. So we could see that that's cos, right? So the cos of 37 degrees, we actually have the angle this time. So we don't have to invert nothing. The cos of 37 degrees is adjacent over hypotenuse x, right? I'm gonna carry the x over, so it'll be x cos 37 equals to 11. And then I'll bring the cos 37 over, so it'll be x is equal to 11 divided by cos 37, right? Which is 11 divided by cos of 37 to the nearest tenth. So this is 13.7. You all got that?
I got 13. over.
Oh, yeah.
Me too.
Actually, no, it is 13.8. Sorry, I didn't round it up. All right. Soraya, Caitlin, did you all get a chance to do these questions, or you skipped these ones? All right. So in this one here, you could see that we have the adjacent, and we want the opposite. So it's tan we have to use, right? So the tan of 32 is equal to the opposite, x on top this time, over the adjacent 13. So therefore, I'll just carry the 13 over. Tan 32 is equal to x. So therefore, x is equal to 13 times the tan of 32. You all got 8.1?
Yes, sir.
All right.
Okay.
Over here we have 51 degrees. We're dealing with adjacent and opposite, so we're talking about tan again. So the tan of 50.1 degrees is equal to opposite, which is x, over adjacent. So therefore x is equal to 5 tan of 50.1. X is equal to what? 5.9. Well, I guess you could round it up to 6, right? 6.0?
Yeah.
Yeah. Nice. And then over here we have hypotenuse and adjacent, so that is cos. So cos of 60 is equal to adjacent x over the hypotenuse 11. So x is equal to 11 cos of 60, which is 5.5. Soraya, how do you feel about these questions here?
I didn't get a chance to do them, but
How do you feel about them though? Are you okay with them? I mean, I just whizzed through it real fast there. You want me to do one a little slower? Okay, no problem, right? So remember what we were saying here is all the time we were using this cos inverse thing, right? And sine inverse, we were using the inverses, right? But why were we had to use the inverse? Because we wanted to find what the angle is, right? Remember, the cos of an angle is what? Adjacent over hypotenuse, right? So if I want to find what the angle is, I have to fling the cos over, so it becomes cos inverse of adjacent over hypotenuse. You're cool with that, Soraya, right?
yeah.
Right. But in this case, you can see that we don't have to find the angle. We have the angle, so we just have to decide which trig to use. So we have so, ka, toa. And what are the sides we're dealing with here? Well, this side here, the side that we want to find, that side is the adjacent. And then this side here is the opposite. So I see I'm going to use tan, right? I have the angle here. So I could just put tan of 41, right, which is that, is equal to the opposite 4 over the adjacent, which is x actually. X, right? So now we have to make x the subject to the formula. So I'll fling the x across here, so it'll be x multiplied by the tan of 41 is equal to 4, right? And then I'll take the tan of 41 and fling it across, so it'll be x is equal to 4 divided by the tan of 41, which is 4 divided by the tan of 41. You all got 4.6 for this? Right. Soraya, how do you feel about it now? Okay. So what I was saying here is that we have the angle, so we don't have to do no inverse thing. We just have to decide which trig to use. So what do we have here? We have the hypotenuse, and this is the opposite. So which trig should I use for this? So what I'm saying here is that this this we have the angle here. We just have to decide which trig to use. Yeah. So this here, we can see that this is the hypotenuse and this is the opposite. So which trig should we use?
Sine?
Yes, because it's SOHCAHTOA, right? SOHCAHTOA, you understand? Hello?
Yeah.
Right. So with sine now, we're going to use sine. We have the angle there. So we're going to have just the sine of 57. Right? And that is equal to opposite over hypotenuse. So the opposite is 10.8 over the hypotenuse, which is x. That's what we want to find. So now we have to make x the subject of the formula. We're just going to throw the x across. So it'll be x multiplied by sine of 57 is equal to 10.8. And now we're going to take the sine of 57 and throw it across. So we're going to get x is equal to 10.8 divided by the sine of 57. And that is 10.8 divided by the sine of 57. It's 12 point. Did you guys get 12.8 or 12.9 for this?
I got 12.
Okay. So Soraya, you understand how I did this?
Yeah.
Right? It's just a matter of just using these, right? So at the end of the day, we have here this is the angle, this is the hypotenuse, and this is the opposite. So sine is what we're going to use. You can see here sine is opposite and hypotenuse. So the sine of 37 is equal to opposite, which is x, over the hypotenuse, which is 10.3. And just fling the 10.3 across. 10.3 sine of 37 is equal to x. Well, nothing to fling across there again. X is 10.3 times the sine of 37 is 6.2. Am I right here? You guys got 6.2 for this one?
Yeah.
Alright.
Yes, sir.
Right. Now let's just go to the solve the triangle ones. Right. This is the one that Caitlin said she did up to number 17. Right. So solve the triangle means that you need to find all of the missing angles. So we had to find this missing angle there, and you also we have this angle here, and you also need to find all of the missing sides. So we have this side here, we need to find this side and this side. So that's what solve the triangle means, right? What do you think is the first thing we should look for, the first thing that we could get? Which side did you look first? Right. Well, let's look at what we have. We have this angle here, right? And I'll just write on the side here, SOHCAHTOA. Right? We have the angle here, and this side here is what? Opposite end. So that means that we have to use either a sine or a tan, right? So if you want to use sine, then we'll be able to find the hypotenuse. If you want to use tan, then we'll be able to find the adjacent, right? So let's use sine. Sine of 62 is equal to opposite, which is 22.6, over the hypotenuse, let's call it h. So h is going to be 22.6 divided by the sine of 62, which is 25.5. Right? Now it seems correct to me because remember the hypotenuse is the longest side, right? Let's see now. We don't need to use any more information. We could go straight to the tan. and find the adjacent side here. So let's use the tan of 62 is opposite, which is the same 22.6 over adjacent. Let's call it A. Right? So therefore the adjacent is equal to 22.6 divided by the tan of 62, which is 22.6 divided by the tan of 62 is 12.0. So this here, and it'll look in 12ish in terms of how short it is. 12.01, right? So did you guys get 25 and 12 for these lengths here, these sides? Anybody got it?
I got it.
This question messed you up?
Yeah, but I was trying to figure out why.
How come this one messed you up? What did you do wrong?
I guess it was both of the different.
Okay, but you didn't get 25 or 12. How about you, Shazin? You got 25 and 12?
I got 25.6 pretty top.
Yeah, 25 and 25 point, how much ever, don't matter. Right? Yeah, 25 and 12, 25.6 and 12 here, right? So I just checking to see if my answers were correct. Next thing you know, I make a mistake, right? So you notice though that when I found this here, I used the information that was given, right? First of all, the first thing I did was I decided what information was given. I was given the angle and I was given the opposite. And because of that, I could see that the two trig ratios I could use with opposite in it is tan and sine. So therefore, I can immediately use tan and sine to find the hypotenuse and to find the adjacent, because they both have opposite. So I was able to find the hypotenuse and the adjacent. You notice when I found the hypotenuse, I used 62 and 22. That is the information the question gave me, right? And when I wanted to find the adjacent, I could have very well used cos, and from the cos use this hypotenuse, but I didn't want to do that, because next thing you know, I get the hypotenuse wrong. So you always don't want to depend on your answers. Use what the question gives you. So I used tan to get 12, right? So let's see how could we get this angle over here. What do you think we should use for this angle? Anything, and we'll have to use one of these. So we'll say, let's just say opposite over adjacent. Let's use tan. So the tan of the angle A, it is the angle A actually, is opposite, which is 12.01 over adjacent, which is 22.6, and I wrote opposite here, by the way. This is the adjacent side, because this is the angle we want to find, and this is the opposite side over here, right? So A is equal to the tan inverse of this, which is the tan inverse of 12.01 divided by 22.6, and we get around 20, which is the answer. Let's look at what we have first. So what we have here is we have an angle and we have the opposite side of the angle to this angle. That's the opposite side, right? And I think I know what is your issue, Scotia. We'll see the issue just now, right? Just because we have this angle, this is the opposite side. But if it is you want to find this angle, Scotia, you can't use this as the opposite, you know? And I think that may have been what you did, yeah? But when you change the angle, you change perspective. So now this side is the opposite. And you understand what I'm saying?
Oh yeah, I made that mistake.
So that's the mistake you made, right?
Yeah.
Yeah, yes. And I know that. And that is essentially it, right? So this is the angle we have. We have the opposite side to that angle, right? So what can we use? So so you can see, because we have the opposite, means that we could use sine to find the hypotenuse and tan to find the adjacent. So let's do that, right? So we could say the sine of 51 degrees is equal to opposite, which is 9, over the hypotenuse. So therefore the hypotenuse is equal to 9 divided by the sine of 51, which is 9 divided by the sine of 51, 11.5, 11.6.
Yeah, I got it.
Alright. And now let's use tan. The tan to find the adjacent. So this is 11.6. Alright. Let's find the adjacent now. I'm going to use the tan of the same angle. The same angle you are working with, 51 degrees. And that is what? Opposite, which is 9, over adjacent. Right? So let's just say the adjacent A is equal to 9 divided by tan of 51, which is 9 divided by the tan of 51, 7.3. Got that?
Yeah.
Nice. So now we want to find this missing angle here, and we could do it. Let's use this 9 because the question gave us that 9, so I'm sure it's correct. So remember, in terms of this angle now, right, this will be the hypotenuse, but this here is now the adjacent. This here is now the opposite. Alright, so let's use sine opposite. No, let's use cos adjacent. So the cos of this is the angle B. So the cos of the angle B is the adjacent 9 over the hypotenuse 11.6. Therefore, B is the cos inverse of 9 over 11.6, which is cos inverse of 9 divided by 11.6 is 39.2 degrees. Okay. So let's take this one, and again I am going to look at what I have first. I have the angle here. That means that this side is the adjacent, this side is the opposite, this side is the hypotenuse. The hypotenuse is always opposite the right angle, right? So let's just make a note. So right? So essentially, what are we saying here? And remember here now, all of these questions I do in, this is the only thing I use in, you know. It's not rocket science. This is the only thing I am using, right? So so let's just see. I have the hypotenuse here, right? So I have the angle and I have the hypotenuse, which means that sine is the only thing that have hypotenuse. Oh no, cos have hypotenuse as well, right? So I could use the sine to find the opposite, and I could use the cos to find the adjacent. You understand up to here, Shazay?
Yes, sir.
So let's use sine. The sine of 53 is equal to opposite, which is what we do have, over the hypotenuse, which is what we have. So therefore 5 sine 53 is equal to opposite. So the opposite is 5 times the sine of 53 is equal to 3.9. 3.99, or you could use 4 if you want. They say the nearest 10th, right? What
Yes,
is would you all put for this? 4?
Yeah.
4.0, right? Now, so what are we saying here? This is about 4.0, right? Now let's use the cosine of 53. Is the adjacent, which we do have, over the hypotenuse, which is 5. So therefore 5 cos 53 is equal to the adjacent, which is this side here. So the adjacent is equal to 5 cos 53 is 3.0. So is that what you got? 3.0? Shazay? Shazay, hello?
It's 5 cos 53.
Yes, yes. Cos 5 cos 53, yes. Because it was cos 53 is adjacent over hypotenuse, eh?
Yes, sir.
Alright, so 53, this is the adjacent which we wanted to find, and this is the hypotenuse which is 5, right? So adjacent over 5, and then I just throw the 5 over, so you're going to be 5 multiplied by that is equal to adjacent, right?
Yes, sir.
So adjacent is 3, you understand?
Yes, sir.
Alright, nice. So, so if this is the case, then we have all 3 sides. Now, we want to find this angle. Now remember, this angle here, this was the hypotenuse, this was the adjacent, this was the opposite to the angle. Yeah? But if you're changing the angle, we want to find this angle, the angle A. This is always going to be the hypotenuse, but now this has become the adjacent, and this side is opposite the angle. You understand that, Shazay?
Yes, sir.
So if you want to find this angle now, just know that the ratio does change depending on the angle that you're looking at it from. So we have all of the sides here. So let's find let's use sine. We can use any one because we have all of the sides. But sine of A is equal to the opposite. The opposite is 3, and 3 all over the hypotenuse, which is 5. And therefore A is equal to the sine inverse of 3 on 5, which gives us 36.7 degrees. Let's go, Shay. Got 36.7 for this. We see here, well, the first thing I'll do with any tricks question is Sukadoa. Okay. What am I saying? Well, this is the angle that I have. This is the hypotenuse, obviously. This here is the side that's opposite. This is the adjacent. So what do I have? I have the angle and I have the adjacent. So I could use these two. Yeah, that is the two that have adjacent in it. Right? So let's do the cos. With the cos I could find the hypotenuse, and with the tan I could find the opposite, right? So the cos of 28 is equal to the adjacent, which is 6, over the hypotenuse, right? So therefore the hypotenuse is equal to 6 over the cos of 28. I skipped a couple of steps there, so I hope that you guys following that. Is equal to 6 divided by the cos 28. Scotia is 6.8 for the hypotenuse here. Number 24. I don't know if you got 6.8.
Yeah.
Right, thank you. And let's just use the tan to get the opposite real quick. So the tan of 28 is equal to the opposite O over the adjacent, which is 6. Yes? So therefore O is equal to 6 tan 28, which is 3.2. I hope I got that right. So 3.2. So I found my 2 sides, and now I have all 3 sides. Now I could work on finding this angle over here. Now when we're talking about this angle now, all of this opposite and hypotenuse, what is one? 6 point, right. Yeah, everything changes now. So this is going to remain the hypotenuse, but now this becomes the opposite, and this is the adjacent over here. Right? So so in order to find that angle, let's use tan opposite over adjacent. So tan of the angle A, this is A, so the angle A is equal to opposite over adjacent, which is the opposite is, I don't know how to write all that. Opposite is 6 over the adjacent, which is 3.2. So therefore A is equal to the tan inverse of 6 over 3.2, which is 61.9 degrees. Alright, so find the angle of elevation of the top of a flagpole. So I have a flagpole here, which is 31.9 meters high, from a point 55 meters away from level ground. 55 meters and on level ground, and this is the angle of elevation. Oh God, the way to find this angle here is, does it get easier than this? I mean, our leaders really want to complain about these worded questions. I mean, just because you see words. Did you guys get this diagram at least? Yeah?
Yes.
Lovely. Very good. I think it was Morphorum Trees. Morphorum Trees was like, Dread, it have words. Anyways. So what are we going to use? This here is the adjacent and this here is the opposite. So we're going to use tan. So the tan of, let's call it E, the angle of elevation. So tan E is equal to opposite 31.9 over adjacent 55. Therefore E is equal to the tan inverse of 31.9 over 55. And that gives me tan inverse 31.9 divided by 55, about 30.1 degrees. Anybody got this?
Yes, sir.
Lovely. Very good. Good. Caitlin, you didn't get this? From a window 15 meters up, the angle of depression of an object is 22. So you're macroing, right? This is the side of the building here, and this is the window here where you're looking down from, right? And what they're saying is from the window 20 meters up, you're looking down. So this here, remember you had to take this here as being the 20 meters, and then you're looking down at an object, yeah, and you're only looking down 20 degrees. So you're looking down 20 degrees at an object. What they want you to do, and you know here, this is the object here, right? Let's call it the object O, and you know that this is 20 meters high because you are 20 meters high, and you're looking down 20 degrees. How far away is the object? You don't think these are useful skill to have? Especially since it's so easy to build a thing to measure that angle, 20 degrees, right? Oh, is it 15? Oh, sorry. Thank you. 15. I just see the angle 20 and I'm doing 20. Yes. The window is 15 meters up. So therefore this is 15, right? And they want you to find how far away. So they want you to find the adjacent side here, right? So we have adjacent, we have opposite, we're dealing with tan. So the tan of 20 is equal to opposite, which is 15 over the adjacent A. So therefore A is equal to 15 over the tan of 20, which is 15 divided by tan of 20, 41.2. You got this, Scotia? So from a point on level ground, so I guess I'm on level ground here, and this is the point on level ground, 40 meters away, the angle of elevation to the top of a tree, so I have the tree here, right? And from here to the tree, on level ground, 40 meters, so this is 40 meters. And the angle of elevation to the top of the tree, so looking up from the ground here, is 32.5 degrees. Find the height of the tree. Now this here is a really popular one that I did with my form trees here, where I actually told them to go and find the height of the house. And how you just find the height of your house? Just measure the distance here and measure the angle that you are looking up at the house at, and you will actually be able to calculate the height of the house. And actually you could do this, use this method to find the height of a skyscraper. You could go to New York, just go a couple of meters away from the skyscraper and look up and measure that angle, and yeah, you could find the height of a skyscraper, right? So we can see here that this is the adjacent, and we want to find this height here. So this is the opposite, and this is the opposite we want to find. So we're going to use tan, opposite over adjacent. So the tan of 32.5, it's 32.5, right, is opposite over 40, which is the adjacent. Therefore, the opposite is equal to 40 times the tan of 32.5, which is 25.5 if we want to keep it at one decimal place. So 25.5 meters. Anybody got this? You did not. Why not?
Yes.
Yeah?
I think I got step up to 40 meters. Like 25.
So you put 40 meters to be the height of the tree.
Yeah.
Oh, yeah. So I guess that is the danger of these worded questions. But look at the words, right? From a point on level ground 40 meters away. And then they actually ask you to calculate the height of the tree. You notice how I draw the tree and everything, huh? Yeah. So, trigonometry is an easy topic. You just kind of have to remember SOHCAHTOA, right? But at the end of the day, we could see, the thing is that you just have to remember SOHCAHTOA. But again, it has so many applications to trigonometry, so many things that you will see it in. When we do coordinate geometry next, we'll have to use trigonometry in there, right? And probably almost everything. When we do vectors, you just have to use trigonometry. Everything we do from now on, we might have to use trigonometry, right? So it's a really important topic to see if we could understand. Now, before we get to the circle theory questions, let's just revise circle theory just a little bit. So we'll just take 2 minutes and just breeze through all of the theorems real quickly, right? Let me just open up. Shazay, if you didn't do it at home, you'll get to do it now. So your time is coming up, sir. So the first theorem, theorem 1, is if you have an arc and you have an angle inscribed by that arc, or if you have many angles inscribed by that arc, all of those angles will be equal, right? So all the angles inscribed by, all inscribed angles subtended by the same arc are equal. That's theorem 1. Theorem 2, if you have inscribed angles from subtended by an arc, at the circumference, the one at the center will be twice the one at the circumference. I hope you remember these things. Because the angle at the center of a semicircle is 180 degrees, means that any angle subtended by a semicircle arc will automatically be 90 degrees. Caitlin, you have problems seeing this one for some reason. I remember that, right? Once you have a semicircle and an angle is subtended by a semicircle, it will always be 90 degrees, right? And then we did some questions, right? 4, we start to talk about cyclic quadrilaterals, and the opposite angles of a cyclic quadrilateral are supplementary. right? So they add up to 180 degrees. That was Theorem 4. Theorem 5 is the exterior angle of a cyclic quadrilateral is equal to its interior opposite. So the hardest part about circle theory is really knowing all of these things, and you really have to know all of these things, and the best way to know them is to do as many questions as possible. Alright, so if you guys want more circle theory questions after this, but don't worry, we'll see more in the exam past papers, right? So now we're dealing with tangents, and this is the easiest one here, and it's the most useful one. Remember that a tangent will always touch the radius of a circle at 90 degrees. So a tangent, the point that it's touching, a tangent is always, no matter where you put the tangent, it is always perpendicular to the radius of the circle, right? Always. Right? If you have two tangents, no matter where you put them, once they come to a point, then they will actually be of equal length, right? No matter where you put them, once they end up coming to a point, they will be of equal length. From that, of course, that is from this point on the circle here to the point, right? So these will be of equal length, and if these are of equal length, automatically you want to start thinking about equilateral triangle, right? But at the same time, you see this 90-degree thing? Theorem 6, a tangent touches a radius at 90 degrees. So obviously we're starting to think about 90-degree triangles. And even this here, even though we have an equilateral triangle, we can just draw a line cutting across here, and now we have two 90-degree right angles. So things like Pythagoras and things like trigonometry will come to play, right? And then we have some questions here. And then we're talking about Theorem 8. Theorem 8 is a bit of a weird one. Theorem 8 says that the angles between a tangent, so we have the tangent there, and a chord. This is not the radius. It's not the diameter. It's not passing through the center. It's a chord. Just a chord. Right? Now remember, this chord is subtended by this arc over here. You see in the arc? Right? That chord is subtended by that arc. And therefore it is that arc that subtends these angles here. Right? And what they say in there is that when you have angles being subtended by an arc, right, and you have a tangent that you draw that touching the chord, right, that this angle will actually be equal to these. So the angles between the tangent and a chord at the point of contact is equal to any angle subtended by the same chord in the alternate segment. Yeah, it's a little bit much. It's a little bit much, but welcome to Form 5. Welcome to exams. And circle theory is pretty much as hard as it gets. So now that we have a little review of the theorems, let's try to get into it, right? You gotta find the length of each tangent. That means from here to here. That is the length of the tangent. From this point here to this point here. You don't have to worry about none of this, right? So you have to find the length of each tangent. So you want to find this and this, right? What you want to find is you want to find the angle APB. APB is this angle here. And we want to find the area of AOP. AOP is this triangle here. Right? So Shazay, let me see it. Firstly, the length of each tangent. How am I doing that? Alright? First thing is find each tangent, right? So the thing is that a tangent, you know, was the first theorems of tangent that we learned. The first theorem of tangents that we learned is that a tangent will touch the radius at 90 degrees. That's the first thing that we learned. So that means that we're dealing with two 90-degree triangles here. Right? The next thing that we learned is that if I have two tangents that meet at a point, they are going to be equal length. Right? So that means that I don't have to go and find the length of each tangent. I just have to find the length of one of the tangents, and then it'll be equal to the other one. So how do I find the length of this tangent over here? Yes, Pythagoras Theorem is an obvious choice, right? Because we have this being the hypotenuse, so this will be C, and therefore this will be A and B. And of course you could just find, so let's quote Pythagoras. Pythagoras Theorem is A squared plus B squared equals C squared. And well, we have A, we want to find B. So let's see, B squared is equal to C squared minus A squared. So B squared is equal to C squared, which is 100 squared, minus A squared, which is 6 squared. No, here me 100 squared, 10 squared, sorry. Minus 6 squared. So B squared is equal to 100, 6 6s are 36. B is equal to the square root of 64, which is 8. You understand what we do there, Shizzy?
Yes, sir.
Yeah, you understand everything we did?
Yes, sir.
So you could see that the first thing I did, what was the first thing I did? The first thing I did was I confirmed what I know. I know, okay, this is a tangent, that means this have to be 90 degrees. Right? I know that this have to be equal to this. Yeah? So if this is 8, that means that this is also going to be 8. Nice. So the first one, Shizzy, were you seeing Pythagoras, or did you forget about Pythagoras?
I wasn't really thinking of Pythagoras.
You wasn't really thinking. Well, I'll just let you know that for tangent questions in circle theory, you will have to know trigonometry and Pythagoras. Yeah, those are the two things that you'll have to know. So now that we have the length of that, Shazay, try your hand at number 2. The angle APB, which is this angle over here. How could we work that out?
Adjacent and hypotenuse.
Which one is the adjacent?
The adjacent is 8.
So yes, 8 is the adjacent. The hypotenuse is 10. But wouldn't that be just finding this angle here though?
Yeah.
Right, and when you find that angle there, then what will you have to do?
Is it not going to be the same?
As this one here, right?
Yeah.
So therefore, when you find this angle here, you have to multiply it by 2 to get the full thing, eh?
Yes, sir.
You understand?
Yes, sir.
Soraya, how are you feeling about all this? I am hearing from you. It's just a matter of knowing your theorems. Knowing the theorems themselves, right? So what we're saying is that we're going to use trigonometry to find this angle. And seeing that this side is equal to this side means that this here is an equilateral triangle, which means that this will cut the equilateral triangle in half, which means that this angle will be the same as this angle. Yeah? So therefore, Therefore, if we could just use trigonometry to find this angle here, then we will be able to just multiply it by 2. So let's do that, right? What Shazay was saying is he was going to use adjacent over hypotenuse. So that's cos. So the cosine of P, let's just call this little small angle here the angle P, right? the cosine of P is adjacent 8 over hypotenuse 10. Therefore, P is equal to the cos inverse of 8 over 10, which is the cos inverse of 0.8 is 36.87, right? So this small little thing is 36.87. Therefore, the angle APB is going to be 36.87 multiplied by 2, which is 73.74. Right? So Scotia, you got any of this?
I got 70.5.
You didn't get the 8?
No.
Oh, well, I guess you used hypotenuse and opposite, so you use sine.
Yeah.
Right. How come you didn't get the 8 though? You was the one who said Pythagoras. Scotia. Alright. Anyways, right? So right. And the area of AOP, how could we find the area of AOP? Oh gosh, that is a half base by height, right? So AOP is a right angle triangle. So we could take the base to be 6 and we could take the height to be 8. So that's just a half 6 times 8. 6 8s are 48. 48 divided by 2 is 24. So this is 24 centimeters squared. Shazay, how you feel about the whole thing?
Yeah, I understand.
Shazay, you want me to give you a chance to do the rest? For homework, I mean?
Yeah.
Alright. So, Scotia, did you do all of them?
Attempted all of them.
Mm-hmm. Are you a little clear about it now?
Yeah.
A little clearer about it, right? Let's just do this one, and then we will we'll call that quits for today. And what we will do is next class is a really important class, guys, especially for my Form 5s. Next class we actually going to do trigonometry part 2. Now trigonometry part 2 is a little I wouldn't say easier. It's pretty much the same thing, different day. You know, it is just like trigonometry 1, how you have formulas to learn, but it's the sides of the triangle that is give you problems identifying the sides to figure out which formula to use. Well, same problem you're gonna have with Trig 2. Trig 2, we're gonna learn just 2 new formulas, right? But it's the same issue where you had to actually be careful about the sides of the triangle. So next class we will do trigonometry 2, and we will take a look at these 4 questions here. 1, 2, 3, 4. So you guys attempt these 4 questions for homework, but let's just do this last one. And Soraya, I would invite you to see if you could attempt it as well, right? Because, you know, I'll line you off the hook, no problem, but you will have to face this next year. So what do we have here? We have we want to find the angle AQB. AQB, that's this angle over here, right? Okay, we want to find the angle. Alright, so I'll put AQB, that's this angle here. We want to find the angle APB. APB is this angle over here, and show that triangle OAQ and BOQ, so that is this triangle here and this triangle here, are congruent. Congruent meaning that they're the same. So you had to prove that these 2 triangles here are the same, and hence show that AQ is equal to BQ. AQ. So let me take it one step at a time. The first thing that they want to find is angle AQB. Any thoughts on how to do that?
What if you how?
How do you know? How do you know that what you're saying here is that this is 63 as well, right? How do you know that this is 63 as well? What if this was 64? What if this was 62? How do you know for sure that that angle is 63? It's correct, you are correct, but I want to know how you know that. First of all, these two tangents will be equal, right? So therefore, if I join here to here, this forms an equilateral triangle, or actually an isosceles, not equilateral, but it's an isosceles triangle. But guess what? This here is the radius, and this here is the radius, which means that this triangle here is also an isosceles triangle. That means that this will be cutting it straight down the middle. And if that cutting it straight down the middle and it's an isosceles triangle, means that this here will be 63 as well. Alright? So, you understand that, Scotia? Is that the reasoning that you used?
Yeah. No.
No, you see, you had to make sure you have a reason, because you can't just be going and jumping and assuming that this is 63. You can't do that. And so you had to make sure you know why. Because this is a radius here, and this is a radius here. So both of them will be equal, and they'll form an isosceles triangle, which means that this line bisecting the isosceles triangle, which means that it's cutting this. So this angle here is 126, and it is subtended by this arc, and it's the angle at the center. So what do we know about angles at the center and angles at the circumference subtended by the same arc, Shazay? Thank you, which means that this angle here is 63. You cool with that, Scotia?
Yeah.
And Shazay, you alright? Yes. Alright. Now the angle APB, which is this angle here. How are we finding that? Right? So first thing is that where the tangent meets the radius is going to be 90 degrees. Yes. Beautiful. Angles inside a triangle is 180 degrees. So this is 90, this is 63. So we could find out what is this little one here. So 90 plus 63 is equal to 153. 180 minus 153 is 27. So if this is 27, then this will be 27 by 2 is 54 degrees. Shazay, you understand how I got this?
Yes, sir.
Alright, so we know this is 54 degrees. Soraya, how are you feeling about all of this so far?
Okay.
It's just a matter of it's just that you don't know your theorems, right?
Yeah.
Okay. Alright, well, let's do the last one. Or maybe I might leave you all to do this one for homework. Show that triangle, this triangle here, this slant one like that, is the same as this triangle here, and hence show that AQ is equal to BQ. How are we going to do that? Shazay, try your luck now. How are we going to show that this triangle is the same as this one? Shazay is frantically going through his theorems there.
Okay. For the triangle to be congruent, could it
It's super easy. And it doesn't necessarily have anything to do with circle theory at all. Because first of all, sir, check it out. Watch how easy it is. This is the radius end.
Yes, sir.
This is the radius end.
Yes, sir.
And this is the radius here.
Yes.
So isn't this an isosceles triangle?
Yes, sir.
Isn't this an isosceles triangle?
Yes, sir.
Right. So therefore, if and now we're talking about congruency, right? So when we're talking about congruency, what are we talking about? Well, that two sides and the included angle have to be the same, right?
Yes, sir.
Right? I have many different things for congruencies, but we could see here that the two sides are the same and the two corresponding sides are the same, right? So we have side, 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 side. So we have two sides are the same. We almost have what we need for congruency. We just had to show that maybe the included angles might be the same, right? And if this here is 63, right, then this here will be 360 minus 127, which is 233. 233 divided by 2 is 116.5, and they do look a little bit. So this is 116.5 and this is 116.5. Right? How do I know that these two angles are equal? Because these two angles are equal here, right? Because they are both angles on a straight line. We could look at this straight line here, and this is 63. Actually, no, it's not 163.5. It's 180 minus 63. It's 117. Yeah, I made a little error, right? So 180 degrees on a straight line. And if this is 63, then you'll also have 117 degrees over here. So therefore, we showed that this is 117 degrees, this is 117 degrees. So therefore, both triangles have side angle side. That is, two sides and the included angle are equal, and hence they are congruent. You understand what I do there?
Yes, sir.
And you see, not a little bit of circle theory, right?
Yes.
Yes. And since they are congruent, hence prove that AQ is equal to BQ, because that is the base of an isosceles triangle. So if I have isosceles triangle here with these two sides equal, and because they're congruent means that that these two will be equal as the base of the isosceles, right? Scotia, you get through with this one?
No.
No, but you understand what I did now?
Yeah.
Yeah, pretty easy, right? Remember, guys, when you are doing the circle theory questions, don't just be looking back at circle theory. All of geometry does come into play. You can see I use congruent triangles. You can see we use Pythagoras trigonometry as well. Well, only for the tangent questions. But you can see here that that we use plenty isosceles triangles, rules for angles. Think about transversals with parallel lines. All of these things come into play with circle theory. Circle theory is not just about the theorems of circles. It have all kind of other things. So for homework, you guys have these 4 questions that I would like everybody, including my Form 4s, to tackle.